Hello everyone, welcome all of you. So in this session 4 we will see about typecasting concept in the Java. So previously we already seen about the different data types in the Java. So Java provides a feature of typecasting by which we can convert variable of one data type into another one. So by using this typecasting concept we can convert byte to short, short to int or int to long. Similarly we can convert long data type variable into integer, integer into short or short into byte. So we can convert integer data type of variables into floating point or floating point into integer as well. Okay, so in the same way we can convert character into integer or integer into character data type variables as well. So in the Java there are two types of typecasting. One is implicit and another one is explicit typecasting. So in case of implicit typecasting, this happens automatically. Okay, at the compilation of your program, compiler will automatically perform this implicit typecasting. So in the implicit typecasting, we are going to convert the variable of small data type, okay, small data type into big data type. So as we are going to assign small value into the bigger data type, we will not lose any data or any precision. Okay, so that's why it is safe. Okay, so implicit typecasting, it happens automatically, in which we convert small data type variable into bigger data type and there is no loss of data, and that's why it is a safe typecasting. So when we write the Java program and we need to perform the implicit typecasting, we don't need to do it manually. Compiler will handle it automatically. But in case of explicit typecasting, we need to do it manually. Otherwise, you will get error at the compilation time. So here we are converting larger data type variables into smaller. Okay, so as we are assigning a large value into the smaller data type, there is a chance of loss of data. Okay, so there is always a risk of data loss. So simple examples for the implicit typecasting. We created byte variable is equals to 10 and I am assigning that byte type of value to short s variable. Okay, so I am not getting any error because short is bigger data type as compared to byte. Similarly here we are assigning the value of s to integer type of variable I. Okay, again integer is a bigger data type, short is a small data type as compared to integer. And at the end we are assigning value of I to long L variable. Okay, so among these four, long is the biggest data type. So we can easily assign the value of smaller data type variable to bigger data type variable. Okay, so you will not get any error. So at the time of compilation, compiler will understand that we are just assigning the value of smaller data type into the bigger data type and there will not be any loss of data, and that is safe. So that's why you will not get any error at the compilation and program will be compiled successfully. So here double is the bigger and integer is the smaller data type. So you can easily assign smaller to bigger. Similarly, again we have character, right? Character C is equal to, let's say I created character A. Okay, so character is a smaller data type and I can convert it into integer. So integer K is equals to C. So are we getting any error? No, because character takes 2 bytes, right? 2 bytes of memory and integer takes 4 bytes. So you can easily use the implicit typecasting for converting character into integer. So when we write character C is equal to A, it is going to store ASCII code value for this character capital A. So ASCII code for this capital A is 65. So when you are converting this character C into integer K, in the output you should get 65 only. You will not get character A here if you print the value of K. So here you will get the 65. So here if I print value of D, here you will get 500.0. So we are simply converting integer into double. So implicit happens automatically and there is no loss of data. But when you are going to convert larger into smaller data type variable, then you will get error at the compilation and that we need to handle explicitly. So S2 is of short type, which is a smaller data type variable, and num1 is an integer, which is a bigger one. So at the time of compilation only, compiler is checking that you are assigning a larger data type value into smaller data type variable, then either you can provide it explicitly that you are okay with the loss of data, and then I can compile the program for you. Otherwise, you will not be able to compile it. So if you run it directly, at the line of 29, you will get possible loss C conversion from integer into short. Okay, so you are trying to convert integer into short, and there is a chance of loss of data. So here we can mention explicitly that I am okay with the loss of data. Please consider short data type value. Okay. So now if we run, compilation is successful. So by using this explicit typecasting, we are able to convert larger data type variables into smaller data type variables as well. So there is a risk of loss of data, so you need to always take care while converting larger data type into smaller data type variables. So let's look at another example. Let's say we create a double num2 is equal to 44.33, and if we try to convert it into smaller data type, let's say integer or short or byte, you will get the error. So integer, let's say num3 is equals to num2. Okay, so integer cannot store this floating point value, right? It can only store 44. Okay, so if you are assigning this double type of value to integer type of variable, there is a chance of loss of data, and that's why compiler will not be able to compile this program for you. So if you run it, you will get the error that possible loss of conversion double to integer. So if you are okay with the loss after the precision point, then you can mention here in the round bracket that okay, consider integer value from this num2, and let's try to print it. So here, as we are okay with the loss of data, here you will get the 44 only. So this 0.33 is lost. Okay, you got the 44. So here we got loss of 0.33 value. So let's look at one last example. Let's say integer marks is equal to, let's say I got 250 and I have total marks, say 500. So I got 250 marks out of 500, and if I want to calculate percentage, that will be in the form of float value, right? So float all subjects marks, whatever I got, divided by total marks, and to this value I need to multiply by 100 to get the percentage. So if I got 250 out of 500, ideally I should get, let's say 50%, right? 50.0 as it is a float. But if you run this, you will not get 50.0. Here you will get 0.0 value. Okay, as you can see here, 0.0. So why it is happening? Because all subjects is of integer type and total marks is are also integer type. So when you divide integer by integer value, the result will be integer. Okay, so here what we got, 250 divided by 500. So we got 0.5. But as result will be integer, as both the operands are integer, from this 0.5, Java will consider only 0 value before this floating point. Okay, so here 0.5 will be lost and you will get 0. So 0 multiplied by 100, here you will get the 0. So finally it will be converted into float value 0.0. So that's why we are getting 0.0 here. So to solve this, you can make this all subjects as float or total marks as a float. Okay, so either of this operand should be float, and then result will be float. Okay, if you divide integer by float or float by integer, result will be float, and at the end you will get the correct percentage. Okay, so let's try that. Let's say float all subjects, and let's run it now. So as you can see, we got 50.0 now. And second solution is, instead of making this all subjects marks as a float, we will keep it integer only, and by using the explicit typecasting concept we can do this. So all subjects marks, before it round bracket, in the bracket I will write float. Okay, so I am telling compiler to consider float type of value for this all subjects marks. Okay, so even though it is a integer data type, but consider float. So I am telling here at the time of compilation convert this all subjects mark into float and then calculate the result. So here also we will get 50.0 now. So this is all about the typecasting in the Java, its different types, and how do we perform it in the Java programming. So thanks for watching guys. I will see you in the next video soon.